Is everyone doing okay today? Yes, yes. Y'all doing all right? Have a good weekend? No, not a good weekend. A couple of announcements for you. I did send an email about this, but I wanted to kind of show everyone also what I'm talking about. I'm going to go to our website here for maybe see if the school's website's up today. Things look good. Okay, so I've kind of changed something. I was kind of going crazy with our media site, which is where I had been putting where I've been putting my videos for the past, I don't know how many semesters, and they've been having all sorts of problems, can't figure it out, and I just said screw it. So I went and looked into YouTube again, and YouTube used to have a policy where your videos could only be like 10 minutes long, 15 minutes long, and they've changed it where your video can be up to 20 gigabytes, which if anyone knows computer stuff, that's a huge file. And you can have unlimited number of videos. So it's kind of a no-brainer because YouTube doesn't go down, you know? And so what I've done is I've converted all the videos over. So now, hey, where is it? Why is that not linked? Let me link it real quick. For some reason, that's not linked. Didn't do it again. There we go. So now, if you click on recorded class lectures, it's going to bring up a YouTube screen here that's embedded into our Canvas page. And if you click on the drop down, it'll show the list of videos. The reason it looks so bad is because it's through a projector and the resolution's different, but you can make this full screen on your computer at home. And you can look at the videos. I have them listed out by day. Okay? So, and then also if you want, in the email I sent, if you want to just go to my YouTube channel, it's Robert Math Guy. So if you go there, you can actually access all of my classes. And one thing that's good about that is if you don't go through Canvas and you just go straight to YouTube, here's my YouTube channel. And if you go to playlists, then it has all my different classes. If it says past, that's something from, semester ago, 2 semesters ago. And if you scroll down, you can get to our class, which is college algebra right here. And it has the videos. You can bring that playlist up. Same thing we were just looking at basically, but through YouTube instead. But there's some review stuff here. Remember we talked about factoring? I found some videos that I did back in like 2002 or something like that. So this is like the old version of me doing some videos back like when I lived in an apartment by myself. And I had a little whiteboard on one of my rooms and I used to do like factoring problems and stuff like that. So I think I've got a couple where like my cat comes jumping through the screen and stuff. But there's things like factoring, solving quadratic equations. They're there. So, you're free to look at those also. That's why if you go through Canvas, you can't get to all this. That's why it'd be better to go through the YouTube channel. Make sense? Okay. All right. What's that? Yeah, it's pretty funny, actually. All right. That's all for that. Questions over homework? Anything you want me to talk about today? (23C)? Okay. So today, 13, 14. This is our third class day, right? And it's 9, 3, 13. And we're covering 1.2. No, 2.1, 2.2. Okay. So this is from the factoring section, correct? And which one was it? 23C? 23C. Oh, yeah. Okay. I had a feeling you would ask about that one. So we have x to the sixth minus 7x to the third minus 8. Right? This is the one we're talking about? All right. So the instructions here are to factor this. And it falls under this section. They even tell you it's substitution, right? So in the past, the things I did in class, we had something like x to the fourth, then minus 7x squared, minus 8. I think that one would have been easier for you to do because it had the fourth power in the squared, right? But what I said in class last time on the problem on the right side is I said you take that x squared, that's what you call your u. So that's the same thing we're going to do on this problem. We're going to take the x cubed and make that our u. So just write down u equals x cubed. Now, the reason why this is going to work is because if you look at x to the sixth power, isn't x to the sixth the same as x cubed squared? Isn't it? And what is x cubed? We just said x cubed was what? Was u, right? U is x cubed. So I can replace this x cubed right there with u, and it becomes u squared. So what I'm saying is that x to the sixth is really u squared if we make a substitution. Right? So let's rewrite the whole problem now. We have, what? This whole thing down here. X to the sixth is really u squared minus 7 times, now what's x cubed? U minus 8 equals 0. And now you have to go through the process of trying to factor this. And I'm going to assume that you could do that. You know, given enough time, ... you could get to it, AC method, guess and check, whatever it is. Why did I put 0? I have no idea why I put 0 in there all of a sudden. Take that out. It's not an equation. It was never there to start. So now this would factor to be u minus 8, u plus 1, right? But we're not done because what's u in the problem? X cubed, right? So now I'm going to replace my u with x cubed. Replace this u with x cubed. And then we're here. There any questions there? Now, unfortunately, we're still not done because x cubed minus 8 is 2 terms, right? And it's a cube minus, isn't 8 a cube also? 8's 2 cubed. And then the second one is x cubed plus 1, but isn't 1 1 cubed? So if you wanted to, you could look at it like this. It's x cubed minus 2 cubed, x cubed plus 1 cubed. And now the first set of parentheses is a difference of cubes, right? And the second set of parentheses is the sum of cubes. And each one of those breaks down with a formula. So I'll do this up here. All right, I'll do the x cubed minus 2 cubed first. That one breaks down to be x minus 2, x squared plus 2x plus 4. Now, where am I getting that from? That's a formula, right? It was a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. I wrote that down in class last time, right? But for us, a in our problem is x, right? A is the x, and for us, b is the 2. So what I did is I rewrote that entire yellow part using x to be a and 2 to be b, and this wrote it into this formula. Do y'all see that? Any questions? Now I have to do the same sort of thing for the second part here, that x cubed plus 1 cubed. But that's going to use the sum of cubes formula. Now I'm going to run out of room on screen here, so it's times, the next thing would be x plus 1, and then it continues, but I'll have to come down a little bit. X squared minus x plus 1. And that's it. That's using this from last class also. Questions? Does that help? Who asked that? Valerie? Who asked that? No? Okay. That okay now? Yes? So was it the part of the substitution or was it after that? Yeah, okay. Yeah, the main thing to remember is that when you're going to try substitution, try using the variable and the power that's in the middle term. And then make sure that when you square that, you get the first one. Like we looked at x cubed, we said, oh, if you square it, you get the x to the 6th. Like if that had been x to the 5th up there, this wouldn't have worked. Okay? But the only thing I'll ever test you on is an x squared in the middle, an x to the 4th, or maybe an x cubed and an x to the 6th. I won't go any crazier than that. Yeah. Okay? Anything else? All right. So today, as I said before, we are going to cover 2.1. Now this is usually still review for most students because we're going to talk about lines. But I'll treat it like maybe it's been a while and you don't really remember everything about it. Oh, wait a minute. Hold on a second. Yeah. What does our schedule say we're supposed to do today? Did anyone print the schedule? Just curious. Does it say 2-2 and 2-3? Yeah, I put the wrong thing down when I put that up here. Let me just edit this real quick. 2-2 and 2-3. Thank you. All right, so we're going to go with 2-2 first. And 2-2 is graphs of linear equations. So to start this out, again, I'm kind of assuming you've seen lines before, right? Lines. How many of you've graphed a line? At some point in your life, you've graphed a line, right? Okay, so this should be some sort of review, but let's talk about what these linear equations, what they are, what they look like. So all linear equations that we will deal with usually have this form. Okay, a times x plus b times y equals c. Here we have a, b, and c are just numbers. X and y are what we call the variables. The only condition that we have, and I won't write it down, is that you can't have a and b both be 0 at the same time. That's the only condition we have. Because if a is 0, then there's no x, right? If b is 0, there's no y. So then it's no longer going to be the line, okay? So I'm not going to write down. You're never going to face that, but that's the one condition we have. So a lot of people are comfortable with that. They've seen something like that before. Let me give you an example of that below. 4x minus 3y equals 1. Right? That's a linear equation. And I'll be able to ask you in a few minutes to graph this, right? And we'll have a way of graphing it. We'll have actually multiple ways. But we first need to know what we're looking at. So if we match it up with what's up there in the general form, A here for us would be what? 4. B would be negative 3. Careful with the sign there. And C would be 1, right? Okay. Now, what we're going to look at now are the two methods to sketch, or if you want to say graph, lines. There's more than two, but these are the two that are commonly taught. The first method is called the intercept method. And the other one's called the Slope-Intercept. I'm just going to put INT method. Now, we'll talk about the intercept method first, and then we'll go to the slope-intercept method, and then we'll start doing some examples. Okay, for the intercept method, let me start with that. For step 1. What we do is we use the fact that when you have a graph and you have a line, so I'm just going to draw some arbitrary line here, that line, as long as that line is not vertical, and as long as it's not horizontal, as long as there's some slope to it, right, it should hit both the x-axis and the y-axis, right? At least one point, at least one time, the x and y will be hit. As long as there's a slope to the line, some sort of slope, then it should hit at those 2 points. So the way we go about graphing it is we find those 2 points and then we draw a line through them. That's the intercept method. We find the intercepts and then draw a straight line. So let's do an example of that intercept method. So here's an example. Let's sketch. How about 2y minus 4x equals 10. And I'll put here using intercept method. Seems so quiet in here. Y'all okay? Still waking up? All right, so the way the intercept method goes is we find each of the intercepts, right? So what we'll do is first we'll get the x-intercept. Now to get the x-intercept, what you always do, anyone remember how to find the x-intercept? You set y equal to, think about it. I'm going to highlight on my graph. That's the x-intercept, right? The yellow one. Anytime you're on the x-axis, what's your y-coordinate? 0, right? If I'm on the x-axis, the y, there is no y. It's on the x-axis, so the y is 0, right? So that's why I come in here and I set y equal to 0. And then once I set y equal to 0, I solve for x. Okay, so here I go. I've got to do this. I take my equation, 2y minus 4x equals 10. Let's set y equal to 0. And the equation becomes what? Negative 4x equals 10, right? Because the 2 times 0 goes away. And now divide both sides by negative 4. And you get negative 5 over 2, reducing that fraction. And then, yeah, we're going to want to plot this, right, on the x-axis. So you can use your calculator if you don't know what that is. 2.5. negative 2.5. This is my x-intercept. So that's where I'll have a dot, right, on the x-axis. And now we get a y-intercept. So how do you find the y-intercepts? For the y-intercept, what's the difference? You set x to 0. And then you solve for y. I'll go through this a little quicker. I'm just going to plug x in 0 for x into the original equation. What would you get? If I plug 0 in, 2y equals 10. And then I'm out of room on the page, so divide both sides by 2, you get 5. So y equals 5 is your y-intercept. I know that's kind of low. Is everyone all right with that? Low on the, I can't scroll up. Now we need to sketch it, right? So I'm going to do a quick little sketch over here. Let's do it right here. And let's see, I'm going to go 1, 2, 3, 4, 5, just each direction 5 or 6. So on the x-axis, I'm going to go where? On the x-axis? Where do I put a dot? Negative 2.5. So that means to the left, 2.5. And we just want to get it close, right? We're not trying to be too precise. Close enough? Okay, and then on the y-axis, 5, 1, 2, 3, 4, 5. So here we go, 5. I'll just kind of highlight my points so you can see them. And then now, draw a straight line through them and you're done. Okay, that all right? No questions there? All right, the other method, okay, the other method for sketching, and we're going to do the same exact problem, requires a little bit of discussion before we go to it. So for the, what did I call it? The Slope-Intercept Method, what we need to do is realize that whenever we have graphs of lines, remember that if you have a line, we just said that it should hit the x and y axis, right? That's why we did the previous method. But there's also another thing we can look at when it comes to lines. All right, if I take this line here, if I pick any point on that line, any point, so I'm going to pick one specific one. I'm going to pick the, what is that? That point, that's the y-intercept, right? If I pick the y-intercept, then, and act like we didn't know where that line was, to get to another point on the line, I could use what's called its slope, right? You've done this rise over run. If you just tell me how much to go up by and how much to go over by to get to the next point, then I would have another point I could draw the line, right? This up part, how much you go up, we call the rise. How much you go to the right or to the left is called the run. And we defined the slope to be equal to the rise divided by the run. And what letter did we use for slope? Anyone remember? There was a letter we used to represent slope. M. Anytime you see M in a linear equation, we are talking about the slope. So here's the deal. With slope-intercept form, what we need are two things. okay, we need, first of all, a y-intercept, and second of all, we need a slope. If we have those two things, we can graph a line. Do you see? That's why they call it the slope-intercept method, because you need the slope and the intercept. Okay? The question is, where are we going to get it from? So what we need to know is a little bit more about linear equations. When you have a linear equation, ax plus by equals c, that's our general form of a linear equation, right? That's what we started with today. If you take this and you convert it by solving for y, if you solve it for y, that means get y by itself on one side of the equation, it will turn into a new equation, and it will have this form. We'll have a new number in front of x, which is m, and a new number by itself, which is b. The m here we just said was the slope. And the b, that number by itself, will always be your y-intercept. Always. So if you're trying to explain this to someone and they give you an equation of a line and they say, hey, we have to graph this using slope-intercept form, what's the first thing you're going to do? Solve for y. Once you solve for y, then you can start picking off what the slope and the y-intercept are and then draw it. Okay? The key is solve for y. So let's do an example. Can I go to a new page, or anyone need this still? Let's do the example that we just did. What was it? 2y minus 4x equals 10? Okay. This time I want you to sketch it. Sketch this using the slope-intercept. So the first thing I'll do is what? Get y by itself. Okay. So here's my y term, 2y. I want to get that by itself. So first thing I'll do is move the 4x, negative 4x to the other side of the equation by adding 4x on both sides. So we'll have 2y equals positive 4x plus 10, right? You can't put the 4x and the 10 together. And then divide everything by 2. Now on the right side, you divide the 4 by 2, and you get 2x, and you divide the 10 by 2, and you get 5. And that now is exactly what we need to do slope-intercept form. Let's now identify the key pieces here. The 2 in front and the 5, right? And it's a positive 5. Okay, the 2 in front is my slope, and will always be your slope. And then this number right here, 5, is your y-intercept. I want to talk a little bit about the 2 first before we finish this off. For slope, if our slope is 2, then we like to write it as a fraction. So how can we write 2 as a fraction? 2 over 1? Because that tells me my rise over my run. Right? If you just have 2 by itself, you might miss the fact that it's actually 2 over 1. The rise is 2 and the run is 1. So let's graph it. So where will I start? Where do you always start with these? You always start at the y-intercept. And I need to make some tick marks here. Let me see. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4. We don't have to be perfect here. Just so I can tell where things are. All right, so we start with the y-intercept. So I go up 5. 1, 2, 3, 4, 5, and I draw a dot there. Now from that dot, how do I get to another point on my line? So rise over run, right? So rise means up 2, and then run means to the right 1. So from that dot, go up 2 and to the right 1. Up 2. I need to draw another tick mark there. So I'll go up 1, 2, and then I'm going to go to the right 1 and draw a dot. You don't need those little jumper things, but that's just to show you I went up 2 to the right 1. I drew a dot. And now from there, you just connect these with a straight line. Questions? That should be the same line we just drew. Should be. So 2 different methods to do the same thing. You could get another point, yes. You don't have to. Because really, you only need 2 points to define a line, right? If I give you 1 point, right? If I just draw 1 point right there, and I say, hey, draw the line through that point, there's an infinite number of lines that go through that point. But if I give you 2 points, there's only 1 line that goes through those 2. So that's all you need are 2 points. You might have been taught to get another one just to make it easier to draw. If you have a straight edge, you can knock it all out in one shot. Okay. All right. We just want to know how to make sure we know how to graph lines. And those are your 2 methods, intercept or slope-intercept. Now, a little bit about some special lines, horizontal lines. And vertical lines. Horizontal and vertical lines are very special, meaning that they don't follow the normal protocol when it comes to their equations. So we know, first of all, a horizontal line is a line that is flat, like this, right? Any line that's just flat is a horizontal line. All horizontal lines have an equation that looks like this. Y equals K. An example would be y equals 2. And let me draw a real quick example of what that would look like. Y equals 2 would go through a y value of 2, and it would be horizontal like this. So that's 2, right? Do y'all see that? So y equals 5 would be up 5, and you draw horizontal. Y equals negative 10 would be down 10, you draw horizontal. So that's the way we do horizontal lines. Vertical lines, right, go straight up and down. And for vertical lines, we write x equals h, where h again is a number. So an example of this would be x equals 2. And a picture for that one would be you go to the right 2 and you draw a vertical line through there. So look at these 2 equations in these 2 examples. How are those different from the equation that I started class with, the ax plus by equals c? How are those different? There's only one variable, right? Like in the first one, there is no x, correct? In the second one, there is no y. So if you have only the y equals a number, that's guaranteed to be a horizontal line. If you only have an x equal to a number, it's guaranteed to be a vertical line. If you have both x's and y's, then it's not going to be vertical, and it's not going to be horizontal. It's going to have some sort of slope to it, right? So what we were doing in the beginning was dealing with the ones that had some slope. Now we deal with the 2 special cases, vertical and horizontal. Okay? One more note about these. the slope of a horizontal line is 0. The slope of a vertical line is undefined. Those are just two things that you should know. Anytime you have a flat line, that's a slope of 0. Anytime you have a vertical line, the slope is undefined. And it has to do with the fact that you divide by 0 when you try and get a vertical line. So just keep that in mind. You might be asked about slopes at some point and of vertical and horizontal lines. The last thing that I want to make sure you know how to do in 2.2 is to talk about parallel and perpendicular lines. Then we're going to do some in-class work because y'all are putting me to sleep. All right, parallel and perpendicular lines. So two parallel lines, parallel, they look like this, right? You've got some line parallel to it, looks like that. Those would be parallel. They basically have the same slope, don't they? They don't hit each other. Okay, so that's exactly the way we're going to define it. Two lines are parallel. Seems warm in here. Am I the only one? Doesn't seem stuffy or anything, no? Two lines are parallel if, what? If they have the what? Same slopes. What do I mean if they have the same slopes? Like if the slope of one of the lines is 2, like 2, the number 2, then any parallel line to that must also have a slope of 2, right? So whatever their slope is, they have to be the same. So I'm going to write one more thing next to this. I'm going to write M1 must equal M2. What do I mean by that? The slope of the first line, M1, the slope of the first line must be equal to the slope of the second line. Is that okay if I write it that way? The little 1 and the little 2 mean first and second line. Okay. That's what it means to be parallel. Most people are okay with that. I've got to switch pages here. What about perpendicular? Yeah, so like if I draw that, perpendicular means it's going to cross that, right? But not just anywhere, right? Like that wouldn't work. Right in the middle. So right through the middle. Like that? No? What do you mean? Close. It's a 90-degree angle. So it must hit like a cross, right? Like a perfect cross. That angle right there we say is a 90-degree angle or a right angle. Okay, that's what it means to be perpendicular. So just any two lines that cross each other, that doesn't mean they're perpendicular. It's if they cross at that perfect right angle. That all right? So these are perpendicular lines. I'll just say perp. Now, with parallel, the slopes had to be the same, right? Perpendicular is a little tricky. Two lines are perpendicular if the slopes are negative reciprocals. Negative reciprocals. What the hell does that mean? Well, in all my years teaching, the easiest way to explain a negative reciprocal is just to give you an example of what a negative reciprocal is. So here's an example. Let's say that one line has a slope of 2, okay? What would a line parallel to this have to have a slope of? Parallel? Also 2, right? But perpendicular, what we would have to do is the other one would have to have a slope that is, first of all, negative of this. So instead of 2, it would be negative 2, but not 2, the reciprocal of 2. What's the reciprocal of 2? So you look at 2 as a fraction. 2 is the same as 2 over 1, right? And flip it over. So it becomes a negative and then 1 over 2, negative 1/2. Let me try another one. Let's say I have a slope of one line that's negative 1/3. A line that would be perpendicular to this would have to have a slope of what? Positive 3. So if it's negative, you switch it to positive. If it's positive, you switch it to negative. So here I change it to positive, and I flip the fraction over. 3 over 1 is 3. Is that okay? That's what it means for two lines to be perpendicular. The slopes have to be negative reciprocals. Now, things are going to get a little bit tricky, all right? We're going to do a couple of examples, and that'll be your turn. New page. Example. Are these lines parallel, perpendicular, or neither? Is that the way you spell neither? That doesn't use the I before E except after C? Well, I ran across this word this weekend, and it really pissed me off when I read it. Because isn't that I before E except after C? No, not here. Not in that case. Why did they teach it to me then? They don't teach it anymore? Do they not teach that rule anymore? I before E except after C. Am I the only one that's ever heard of that before? There's just a bunch of conditions and stuff. Yeah. There's been amendments. Did they vote on it? There was a bunch. Okay, well, that's all I remember is I before E except after C. All right, so I have to give you two lines, right? So you can determine if they're parallel, perpendicular, or neither. So here's the way I'm going to write this. L, that's an L. That's a cursive L. Very rarely do I write in cursive. This is one case. Okay, L1, colon. So here's the first line. Negative 3y plus 5x equals negative 2. L2 is 4x minus 7y equals 14. All right, so what we're going to do is this. You're going to work together on this right now. Let me give you a heads up of how you do this. What you need to do is figure out what the slope of this line is and figure out what the slope of this line is, right? And then compare the two. If those two slopes are the same numbers, then you can say what? They're parallel. If those two numbers are negative reciprocals, then you can say they're perpendicular. But if they're not the same and they're not negative reciprocals, then you'd say they're neither, which means that the lines would do something like this. You know, where they hit each other, but hey, it's not parallel, it's not perpendicular, right? It's possible to be neither. So what I'd like for you to do is figure out in your table with each other, how are you going to determine those slopes? How are you going to figure them out? So go ahead. I'm not going to talk about that anymore. I'll just pause it for now. The other one is what? 4/7 x minus 2. So y equals 4/7 x minus 2. So that one I start at y equals -2 right here. I go up 1, 2, 3, 4 to the right 7, somewhere around there. And I draw a line through those two. Oh, not a very good line there. Oh well. But they're obviously not parallel and they're obviously not perpendicular. Okay? Sorry, I'm going back to this real quick because I didn't videotape that. I just want to make sure that that's accounted for. Okay. Let's start a new page here. I'm really hoping that this is not the first time you've ever seen this, right? You've done lines before. Trust me, at some point, hopefully what we do in here will become new information to you. And then you'll be like, what happened? What happened? This is an example. Find the equation of line through 2 points, -3, 5, and -7, -10. What is it that I'm asking for here? Find the what? The equation. Keep in mind that your final answer should be the equation of a line. So I'm not asking you to find the slope. I'm not asking you to graph anything. I'm asking you to find the equation of the line that goes through those 2 points, right? So if I wanted to, I could go and draw this line. I could go out to left 3, up 5. I could go out, 7, down 10. And I could draw this line. Big deal, right? There it is. There's my line. But I want the equation of it, right? That's what I want, the equation. So there are 2 things that you'll have to know in order for you to do this line, or to do this problem. The first thing that you need to know is the equation for a slope of a line. How can you find the slope of a line if someone gives you the points? See if this rings a bell. Y1 minus Y2 over X1 minus X2. Or you could do it the other way around. Y2 minus Y1 over X2 minus X1. Do those look familiar? Okay. That's how you find the slope. The second thing you need is what we call the point slope equation of a line. Y minus Y1 equals M times X minus X1. Now, students are taught to do this different ways. I want you to see this formula, just in case you haven't seen it. Point slope formula. And why do they call it the point slope formula? Well, x1, y1, isn't that a point on your line? And isn't m the slope of your line? So if I were to give you an x1 and a y1, I would give you a point, right, on the line, and then I give you m, I give you a slope. Then you have a formula that gives you the equation of a line. So that's why they call it the point slope formula. Okay, so that's what we need, those 2 equations. Where are you going? What are you doing? No, I'm just kidding. Have fun. Okay, so let's get back to this example. I gave you those 2 points, right? So the first thing I'm going to do is find the slope. Now I need to label my points. So I'm going to call my first point up there x1, y1, and my second point x2, y2. And you could do it the other way around. If you want the 1s to be on the right and the 2s to be on the left, you can. You just can't mix them up. Okay, it can't be x1, y2, x2, y1. 1s and 2s together. So my slope will be, the formula that I use most time is this one, y2 minus y1. over x2 minus x1. So what would that be for us here? What's y2? Negative 10 minus 5 over x2, negative 7 minus negative 3, right? And you have to be careful there because you're going to get a negative 15 on top, but then you're going to get what on the bottom? What's minus a negative really? Plus, right? So what's negative 7 plus 3? Negative 4. And the negative divided by negative is positive, isn't it? So 15 over 4 is my what? Slope. It's my slope, right? Now, let me go to that second thing I had, which was my point slope formula. And let me replace my y1 with whatever y1 was, my x1 with whatever x1 is, and my slope with what we just found. So this will turn into y minus, what was y1? I got to scroll up here a little bit. 5. So it'll become y minus 5 equals m, which I just found to be 15 over 4, x minus, what's x1? Negative 3. So minus negative 3. Be careful with the signs there again. So I have y minus 5 equals 15 over 4 x plus 3. And that is the equation of the line. Now, you should, though, be able to take it and solve it for y. If I asked you to solve this for y, you should be able to isolate y. So I would take and do that as an exercise here for yourself. Not right now. Solve for y there. That means you would have to distribute the 15/4 through the parentheses, and then after you do that, you'd have to bring the 5 to the other side. So do that on your own, not now. And if you run into any problems on that, get with me or the tutoring lab. Okay. I've covered a lot here. Slope. Yes. All right. Now we're going to do a word problem because you love word problems, right? Okay, here's my word problem. Let's just do like a CPS bill. CPS, energy. Charges. And I'm making this up. Completely making this up. Charges, let's say, $20 for monthly service. Plus $0.0035 per kilowatt hour. So what I'd like for you to do here is sketch the cost versus number of kilowatt hours. And I'll explain this, okay? Let's just get everything written down first. So CPS, if you have a CPS account at your house or wherever you live, then CPS is charging you a certain amount just to have service. Whether or not you turn the lights on or not, you pay to have service. And then it's dependent upon how much you use. Kilowatt hours is the way they measure the amount of electricity you use, right? So what we need to do is we need to try and draw a graph that represents the cost on our y-axis and the number of kilowatt hours on our x-axis, and try and draw the function. So let's start off by writing down some variables. C will be here in the problem, cost. And what do you want the number of kilowatt hours to be? We can use any letter we want. N? I heard N first. N is going to be the number of kilowatt hours. So tell me what the cost is for this person. What is the cost? How much is it going to be? $20. Is that it? Plus 0.003, what did I say, 5? N. N is the number of kilowatt hours, right? So if I use no kilowatt hours, then it's just going to be $20. If I use 10 kilowatt hours, it'll be 20 plus 0.0 plus 3 cents, about 3.5 cents. Right? 0.03 is 3 cents. Okay, let's keep going. Now, does everyone see that this could be written as 0.0035 N plus 20? And that kind of looks like, if you squint your eyes hard enough, y equals mx plus b. See, n is our variable, c is our variable. The number in front of n is our slope, and the number by itself is our y-intercept. Y'all see it? So we have a line, don't we? And since we have a line and it's written in the form y equals mx plus b, we should be able to graph it, shouldn't we? Yes? How would we graph it? Whoa. Where do you start? Y-intercept of what? 20. So let's just put 20 here. Just going to put 20. And up on this axis, I'm going to put cost. And I'm going to put next to a dollar sign. And then on our x-axis, what's our x-axis here? The kilowatt hours, so kWh. Okay, kilowatt hours. So we should have a point at 20, shouldn't we? What's the problem, though, now? The rise and run. We do have the slope, though. We do. What is it? 0.0035. How do I draw that as a slope? How do I look at 0.0035 as a slope? Make it a fraction. Make it a fraction. How in the hell do you make that a fraction? How do you make a decimal into a fraction? There's probably a key on your calculator that goes decimal to fraction. But other than that, let me help you, because a lot of students don't know how to go from decimals to fractions. If I write 1/10, what is that as a decimal? 0.1. What's 1/100th? 0.01. What's 1/1000th? 0.001, right? 1/10,000th is 0.0001, right? So hopefully you were taught at some point in time that the first position here is your tenths, not tens, tenths position. The second one is your what? hundredths. There's a this at the end of that. Hundredths. And then the next one is your thousandths. And then your 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billionths, blah, 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 blah. Keep going. All right? Now, what is 0.35 then? I'm just going to start there. So the way you do this is you count. This is tenths, right? The 3 is in the tenths position. The 5 is in the hundredths. So I just write the number 35 over 100. That's it. That's 35 hundredths. 0.35 is 35 hundredths. If I put 0.035, then what position am I in? Tenths, hundredths, thousandths. So I write what over 1,000? 35. You don't need the 0 in front of it. So this is 35 over 1,000, right? So if I write 0.0035, we are in the tenths, hundredths, thousandths, 10,000th position. So this is equal to what? 35 over 10,000. Shit, that sucks. Right? Because that's what we have, isn't it? Let me go back to my graph. Yeah, that is it, isn't it? Our slope, 0.0035, is really 35 over 10,000. So that means I need to go up by how much? 35, and over by what? 10,000. Now that's okay, because all I have to do is this. If this is a double, that's about 40, right? So I would have gone from 20 to 40, that's 20, right? I need to go up by how much? 35, so I should be up at what number up here? 55? Do you all agree? 20, add 35 to it, and you're at 55, yes? Okay, that's my rise, and then my run is what? To the right? Now, you don't want to go 10,000, but the good thing is that you don't. Your axes don't have to be scaled the same. In other words, I can count off instead of by 1, 2, 3, 4, I can count off by thousands. 2,000, right? 3, 4, 5, 6, 7, 8, 9, 10. So there's 10,000, right? So I put a dot out here like this. There's my line. Draw it. Do y'all see that? I mean, it's a good line. Don't be jealous of how straight that is. Yeah. Oh, man, I just erased that. Why am I erasing? That's weird. Do y'all see how I did that? It should be the 55 comes over in my, so my rise was 35 and my run was 10,000. But see, I put 10,000, oh, well, I know I didn't. I put 1,000. Why didn't y'all tell me that was 10,000? There we go. 10,000. I could have made 10,000 be here, couldn't I? It doesn't matter. The important thing is, can you take the information given and put it onto a graph so that someone reading it can make sense out of it? That's what we're trying to do. Okay, let me, oh wow, it's 10:45. Here's what I'll do. Because we're out of time and I need to get across campus, I'm going to email you your homework assignment. All right? Email. That way I'm forcing all of you to check your email. All right? Everyone have a good day. I'll email it today. Just bring it to class every time. I did not give you a quiz today because it was a 4-day weekend, and I didn't want to do that to you. But I promise you a quiz on Thursday. Promise. First thing, right when we walk in, quiz. Okay? I will keep that promise. You're welcome.